let's start lesson number 3 with a reading from Psalm 15, verse 16. The heavens are the Lord's heavens, but the earth he has given to the children of men. So the earth he has given. The earth is a perfect gift. When we study the we study our solar system, it's easy to look at the earth as one of 9 planets around the sun. And it's easy to take for granted, but it truly is the most marvelous and unique of all the planets. We're going to study the perfections of the earth just to see how perfectly placed it is to sustain life. Completely unique, the only thing like it that we know of in our entire universe. The first perfection I want to talk about regarding the earth is that it's the perfect distance. That's the question. Perfect distance from what? Perfect distance from the sun. 1, 2, 3, third planet out. If we were any closer, like Mercury or Venus, we would be much closer to the sun and therefore a much hotter planet and unable to sustain life. If we were a little further out, my very early morning just started, so Mars or Saturn, then we'd be too far from the sun and all the water on our planet would freeze. So the key concept is, closer to the sun, we'd be too hot, farther from the sun, we'd be too cold, and right there is the perfect spot. I think even if you got rid of the 700 miles in the 92,935,700 miles, it could make a big difference on the planet, as we'll see how the seasons come about later. So keep that concept in mind. Perfect distance, not too hot, not too cold. The next perfection that we're going to talk about in the earth is mass. And so it's kind of a scientific concept. So instead of me trying to explain it, I'm going to actually read it out of the textbook here because I think it does a great job explaining it. Do you have a baseball and a tennis ball? If so, go get them. Hold the tennis ball in one hand and the baseball in the other. These two balls are almost the same size, but as you hold them, you should notice that the baseball is heavier than the tennis ball. Why is that? If they're pretty much the same size, why is one so much heavier than the other? The answer is there's more matter in the baseball than in the tennis ball. So the next question is, what is matter? It's the, quote, stuff that makes up everything around you. Everything you can touch or smell, including yourself or me, is made of matter. The more matter that's in something, the heavier it is. Since the baseball is heavier than the tennis ball, the baseball must have more matter in it, or stuff in it. Now remember, these two balls are pretty much the same size, so if the baseball has more matter in it, what does that tell you? It tells you that the matter is packed into the baseball more tightly than matter is packed into the tennis ball. Think about putting your toys into a box. If you put a ball and a squirt gun into the box, it wouldn't be very hard to lift. However, if you took all of your toys and stuffed them into the box, it would be a lot heavier, wouldn't it? Why would the box be heavier? It didn't change the size, it just had more things packed into it. In the same way, the baseball has more matter packed into it than the tennis ball, so it is heavier than the tennis ball, even though it is pretty much the same size. So that kind of sums up the idea of mass. There's more stuff packed into something so that it makes it heavier. Now let's talk about how that affects something called gravity. And you remember gravity from our first class. It's the invisible force that objects have that pulls on each other. So the more mass that something has, the more gravity it has. So the sun would have far more gravity than the earth, or far more pull than the earth, because it's so much bigger and has so much more mass. And it's the sun's mass that creates the gravity, or the pull, that keeps the earth and all the rest of the planets in orbit around the sun. But the earth has mass too, and the earth has gravity. As a matter of fact, the earth gravity is what holds the moon in orbit around the earth. But it's also what allows us to stay on Earth. So think about this. If there was too much gravity, or if the Earth was heavier, it would pull us down. We'd be tired. We'd constantly be working hard to run or to walk because everything would weigh more. It would be pulled to the Earth harder. But if the Earth was lighter or had less mass, there would be less gravity, and it could be kind of cool. We could jump higher and run farther and lift more. We could fall out of an airplane and not get hurt if there was less gravity. But the downside is if there was less gravity, there wouldn't be enough gravity to pull the rain out of the clouds, and we would have a drought. Or if there was so much less gravity, we could float up and out of the atmosphere. Or when the wind blows, we would be blown about by the wind, and we wouldn't be able to hold ourselves down because there wouldn't be enough gravity on the planet. So speaking of things floating out of the atmosphere, the other thing is if the Earth was too heavy, it would hold poisonous gases like ammonia down on the Earth where we breathe it, and it would be poisonous to us. But we have just the perfect amount of mass or the perfect amount of gravity that the harmful gases are allowed to escape up into the atmosphere and out into space rather than staying down close and trapped to us where we could be poisoned. So the Earth has a perfect mass to be able to hold us to the planet and not be blown around, but also not to make it so it's not too heavy of a gravity that we can't work and run and play. Okay, perfect rotation. So we talked about the two R words, revolve, where the Earth revolves around the sun, or the moon revolves around the Earth, but now we're talking about perfect rotation, which is the Earth spinning around on its axis. The reason it's perfect, which it's 24 hours, and every planet can move with a different rotation. It could be weeks. I mean, theoretically, we could have a planet that could spin around in hours. But ours spins every 24 hours, and it's perfect because of a couple reasons. One is our sleep cycle. Imagine if your day was a month long and your night was a month long. That would really mess up your sleep cycle. So 24 hours is perfect for people because it gives us a night and a day every 24 hours, which is about the amount of time that we need to rest. Even people who live up in, say, Alaska, where the days and nights are longer, still need to sleep on a 24-hour cycle. The other thing that's really nice about the 24-hour rotation that makes it perfect is the weather. If the Earth, or if any planet, rotates faster, do you think there's more or less wind? More wind, you got it. So the faster it's turning, the more wind there is, and it would create hurricane-type winds and cyclone-type winds on our planet. But it's not moving that fast. It moves at a perfect 24 hours. But if it was to go slower than that, then it would mess with our temperature. So picture it moving very slow and the sun having more time to cook and to build that heat. Now you can remember the sun heats it up during the day, and then it cools off on this side at night. So if you're the sun, this side's getting hotter, but when that part of the Earth rotates over here, it cools down. So the warming and cooling effect, if it moves slower, would make for extreme temperatures, hot where the sun side is, and very cold where the shadow side is. So 24 hours is perfect on the Earth for sustaining life. And when we talk about the other planets, you'll see just how unhospitable a faster or slower rotation cycle can make a planet. This next one's a really big concept, that the Earth has a perfect atmosphere. So let's break down this word for a second. Atmos comes from the Latin word that means steam, and sphere, I think you maybe have heard that one before, a sphere is a ball. So an atmosphere basically means a ball of steam. So around the rocky, solid Earth planet, dirt, or the solid parts of the Earth, there's this atmosphere or gases that surround it. It's about 300 miles thick, but there's no stop and start to it. It kind of is really thick near the Earth and then fades away. Most of the atmosphere is within 10 miles. That's why as you get higher in elevation, say on a mountaintop or an airplane, it gets harder to breathe because the atmosphere gets thinner. So it's basically the big ball of steam or water or vapor or gases that surround the Earth. It's also called, usually we would refer to it as the air we breathe. Our atmosphere has a lot of oxygen in it, and oxygen is what we need to live. So our perfect atmosphere is perfect because of the fact that it has oxygen in the right ratio and in the right percentages that allows us to breathe and to live. And it's easy to take it for granted until you try to hold your breath for 5 minutes. And then you realize how much you need that air and that oxygen around you. So this atmosphere around us, it protects us in so many ways. It's like a greenhouse, or when you have like little baby plants and you put them in a greenhouse with the glass roof and the the glass walls. And what that greenhouse does for the little baby plants is it helps them keep from freezing, and it lets you open it up and keep them from getting too hot. So the gases of our atmosphere, and you'll see how this makes a big difference when we study some of the other planets, the light rays come in and they pierce through our atmosphere and they warm the Earth, but then this ball of gases around us helps hold that heat in. If we didn't have the atmosphere, the heat would just radiate back out and our nights could be super cold and we would freeze. So the temperature is regulated just like a greenhouse by this ball of gases. It also shields us from what's called ultraviolet light. That some of the harmful lights and radiation that the sun gives off, our atmosphere absorbs or deflects so that it doesn't hurt us, giving us, cancer or sunburns and things like that. Excuse me. And lastly, it protects us like a greenhouse from rocks and debris. Whether you know it or not, every day rocks are hitting our planet. Whether they're the size of sand or the size of a huge boulder, space debris and space rocks are like slamming into planets in our solar system. But our atmosphere, it creates friction, but we'll cover that maybe in a physics class or something. But it burns them up before it hits, so it acts like a shield. So if a rock is going to hit Earth, it'll hit the atmosphere and it'll start burning up and it'll be incinerated before it hits the planet. Now most of them are incinerated in the atmosphere. It's what you see when you see a shooting star. Just that quick whoosh, burst at night in the sky is a rock or a piece of debris hitting our atmosphere and burning up. And occasionally a few do get through and they hit the planet and impact, but most of them hit the ocean anyway, and it's very rare that rocks actually hit on land or cause any damage on the planet. But just like a greenhouse, the atmosphere protects us, keeps our temperature regulated, keeps us shielded from ultraviolet and harmful rays and radiation, and it protects us from space rocks and debris. Perfect atmosphere on planet Earth. The next perfection is the perfect tilt of the Earth. So in case we haven't covered this yet, the Earth is not straight up and down like this. The Earth is at a tilt so that it rotates at a 23.4 degree angle. And we don't have to talk about angles yet. You'll cover that in math. But that just means it's not straight up and down. Neither is it way off or turning sideways in its rotation to the sun. But if here's the sun and there's the Earth, it's slightly tilted away. Now the important thing, why is that tilt is so perfect, and this may surprise you, is that the tilt is what causes the seasons on our Earth. So at one point to the sun, we're tilted, let's say it's just us here in North America, we're tilted away from the sun. But then, as we come around to this side and we're on that same tilt, and we're in North America, we tilt towards the sun. Now the funny thing is when the sun's hitting something direct, it gets much hotter. So when the beam comes in and hits straight in the middle of the planet, it's focused. But when it gets up to the top of the planet, it kind of spreads out and is less concentrated, so there's less heat. So whatever's tilted away from the sun tends to be cooler. Whatever's tilted towards the sun is hotter. Here's a quick experiment I want to show you. Hopefully it'll help illustrate what light rays do when they hit something at an angle versus when they hit something straight on. So stay tuned and watch this experiment. Okay, here's our experiment. Watch the focused dot right here, and as it tilts, you'll see it spread out and become less focused. And then as I tilt it back, sharpens up, turns into a nice bright dot. One more time. As it pulls back, it spreads out into a longer beam across the surface, and then when it's direct on, tightens up again. More focus. Let's pretend for a minute that you're the sun, there in the camera. This little blue line, if you can see it, right around the planet, is called the equator. That's the place on Earth that gets the most direct sun. So as you can imagine, the equator would be the hottest place on Earth. Let's break down and just show you another term real quick. So the equator divides the world into top and bottom. It kind of cuts the world in half. So it makes what's called a hemisphere. Hemi means half, sphere means ball, so a hemisphere is a half ball. Now, when the Earth, if you're the sun, and here's North America where we live, if this is tilted away from the sun, it's going to be winter up here. But down here that's tilted towards the sun, it's going to be summer. So the top half of the planet, when it's winter, the bottom half of the planet is sun. So when you change hemispheres, the seasons actually rotate. So it's not the same season all over the Earth at the same time. They're opposites based on which half of the Earth or which hemisphere of the Earth you're in, based on the tilt of the sun, or of the Earth towards the sun. Alright, so if the equator gets the most direct sunlight, the top and the bottom get the least direct sunlight. The sun's always kind of hitting it at an angle and never straight on. It almost bounces and reflects off. So now if you remember, the Earth rotates on an axis. So if you could see this little pole right here that goes through the globe, now on the real Earth it's invisible, but it is like an axis or an axle that runs straight through the planet to the bottom side. You can see it right here. So the Earth rotates on that axis. Now the very point where that axis is on both the north and the south are called the poles. So if this piece of metal, which is invisible in real life, is like a pole where it pokes out on the bottom and where it pokes out on the top, that is the north and south pole. So as the Earth rotates, the poles never really move, and they always stay at an indirect angle to the sun, making them the coldest area on Earth. So the equator is the hottest, the poles are the coldest. I want to talk for just a second about the perfect land of the planet Earth. This is my rough drawing of the planet Earth. Up here will be all the trees and the lakes. So the Earth is partitioned into layers from the very middle of the Earth to the top surface where we live. The 4 layers start like this, going from the outside to the inside. We live and stand on the crust of the Earth, this brown portion around here. So think of it like the pie crust around a pizza. And this is the dirt and the rocks and the mountains and the land that we live on. This is about 20 miles thick, and it's just rock and sediment and solid earth. When we get to the next layer, this is called the mantle of the Earth, this pink or red area. The mantle of the Earth is the biggest, most massive part of the Earth. It takes up the most space in the middle of the Earth, and it's made up of melted or semi-solid rock or magma. When it comes out of a volcano, that's what you see as lava. So the Earth is filled with this liquid, hot rock, and that layer is called the mantle. And then once you get past the melted rock, then you have what's called the outer core, or this orange piece. That is made up of melted metals. So the heavier, denser metals are towards the center of the Earth, still hot and melted and swirling. This orange place right here, the outer core, that's what makes where the magnetic fields of the planet are generated from. And we're going to cover that in just a second. So this orange place is called the outer core. It's the melted metals. And then when you get to the very, very middle of the Earth, the inner core, or this black part, it's actually made of solid metal. These metals are mostly nickel and iron, not nickel like the coin, but it's a metal called nickel, and iron. I'm sure you're familiar with iron. So it's a melted and swirling nickel and iron, and in the middle there's a very solid, hard inner core. Alright, so we're at our last little piece here of the perfections of planet Earth, called the magnetosphere. Some of these concepts are pretty hefty, and so be sure to take a look at the supplemental material that goes with this videos, and of course we're going to talk about this a lot more in class. But the magnetosphere is another perfection of the Earth made to sustain life and allow us to live on this planet in a very unique way. Magneto has to do with magnet, and sphere has to do with ball. So it's a ball of magnetics around our planet. And magnetics, just like it is with refrigerator magnets, they repel and attract things. What does it need to repel and attract? Well, you may ask. Well, the sun is always giving off what's called solar wind. And the solar wind is the energy that's being emitted from it. And there's a lot of harmful things in that solar wind, radioactive things, things that would not foster life on planet Earth. So, and especially, last class we talked about solar flares, which shoot out huge blasts of solar wind. And so when the solar wind hits our magnetosphere, they're either reflected off or repelled or attracted and drawn into the poles of Earth. And we talked just a second ago about the poles on planet Earth. So this magnetosphere protects us from the harmful things in the solar wind, protects us from the harmful things that come from solar flares. And like we talked about, as they get drawn into the magnetosphere and pulled to the poles, that's where you see the northern and the southern lights at the two poles, where those radioactive particles are trapped and drawn in. So I want to close this lesson by reading a quick verse from Isaiah. It's Isaiah chapter 45, verse 18. Just speaking of the perfection of the planet Earth in relation to the rest of our solar system. For thus says the Lord, who created the heavens, He is God. Who formed the earth and made it? He established it. He did not create it empty. He formed it to be inhabited. So here we see all these perfections of planet Earth, without which, if one of them was missing, this planet would not be inhabitable, making it this glorious, unique, one-of-a-kind planet in our solar system and in our universe. See you in class.